तुमचं नाव
Good morning, all. This is Amey Tambe. Without much further ado, let's start with today's session. Is my audio audible to all?
Yes.
Okay, great. Yeah. Okay, so just let me share my screen. Okay. Is my screen visible to all?
Yes, sir.
Great. So, very good morning, and I personally thank you, HOD sir, for inviting me for this FDP, and I'm very much glad to deliver this FDP to all the aspirant participants. So, thank you once again, and let's start with today's session. So, today's agenda for session is we will be seeking information about how exactly the IoT, Internet of Thing, is work, or I'm not taking a very general thing like what is IoT and how we can do in that. So instead of that, or not the instead of that, along with that, what I can do is will have some practical demonstration of some sensors. Then I'm having a pretty much development boards with me, so I can show the development boards to you, how the development boards are interfaced between sensors, actuators, then we have modules, and how we can create some sustainable products out of it. So our aim is to understand how exactly these all sensor bed, we can say these all are the sensor beds. So all these sensor beds, how exactly these are connected with each other with the help of development board. And when we are trying to develop any kind of a product, then instead of a development board, how we can take out the particular IC or particular circuit, and we can print it on a PCB. Of course, printing the circuits on a PCB is not possible on this online session, so I'll be not doing that. But definitely, I can show you how to create a circuit diagram for that. Now, these all demonstrations or practical what we can see, these can be done at your end also. So what we can do is some of the participants are having hardware with them, so they can practice it on the hardware along with me, or on the tomorrow's session or the first half, I'll be giving information about the online simulators and how we can simulate the exact environment what I'm doing here with the actual hardware. So those are not having hardware with them, they can do it on a simulator and they can get a similar kind of effect. But only the thing is, you will be getting it on the virtually. Now, before moving on the hardware part, like here I'm just holding up a Arduino Uno, which is most favorite and recommended development board in the series of what we can say cost effective development boards. So Arduino is the best choice, and of course this is not a genuine Arduino, as this is a first copy of it, because first copy of this development board is easily available up to 500 or 600 rupees in the market, and original will cost you about 10 times more than that, 5,000 or 4,000, 5,000 of it. So for if you are a beginner, then you can get this clone version. Now again, I'm not recommending you to get a pirated version, but this is not the pirated version, as the entire circuit diagram what we can see, or the entire assembly, is a open source assembly. So we called this kind of a structure an open source assembly structure. So open source assembly structure is available for all the manufacturers to develop their own boards. So furthermore, if we are creating any application, like in our inauguration session, uh, uh, Dr. V.P. Poddar sir have mentioned very correctly that the IoT is nowadays applicable in all kinds of industry, whether it is automotive, whether it is health sector, or whether it is then he mentioned that the weather station we can create. Of course, we can do all these things with the help of IoT. Now we can develop all these kind of applications on a very smaller case, or we can create it on a larger scale, as we called it as a industrial scale. So that IoT now in that term will transform, or it itself evolved or itself transformed into a IIoT, that is industrial internet of things. So uh, before let's interfacing this, let's understand some basic architectural things of IoT. I'll just take it very quickly. I know that all your participants are very eager to see all the development boards and how they look like and what are the pinouts of it, and how we can integrate various sensors and circuit to it, and we can have something running. So but before that, this is a very important part to understand. As we are a IoT developer, as the definition suggests, that Internet of Things is what it is: a connected devices. In a short, it is a connected devices. So it doesn't mean that every device has to communicate on the internet. Any device which is having a capacity to communicate on a network, that device considered as a Internet of Thing device. So thing is what it is: a thing. It is a part, or it is a circuit that we refer as a thing, and it is having a capacity, or it is able to communicate on a network. That's why it's called as a Internet of Thing. And Internet of Thing, why it is called Internet of Thing, then why it is not called network of thing? Because it is going to communicate on the network. But most preferably, you would like to control your devices or appliances, if you can see in home automation or office automation kind of applications. Like when you enter into a room, automatically light, and if it is a summer season, then fan or AC needs to be switched on, and it needs to be in a perfect speed in refer to fan, and in a perfect temperature for the ACs. Then when you walk out from the room, it needs to be turned off to save your energy. Then if you are going into a kitchen and you wanted to blend something in a blender, that blender needs to be controlled by application, and automatically you can whatever you wanted to blend, you can do it. So that is a pretty home automation part. Then you can have automated geysers or water heater systems. So there are a lot of possibilities what you can have with the automation. So if you wanted to apply all these kind of things, so this is a very general example. And if we can take it on the larger scale, then if you're walking on the street, then automatically if you are on a zebra crossing, and you are having an emergency, like some kind of emergency, and you wanted to cross that road, then AI enabled smart poles are there which can sense your activity and can trigger a emergency alarm and automatically controls the lights. Now this is a very difficult to implement in India, but again, it is a POC project. POC is what? Proof of concept. So it is a conceptual project which is worked in some other countries, but definitely we can try it out in India. But it is very difficult, because in a normal situation also, some riders or some drivers are not adhering traffic rules, and now in this situation it is very difficult. But still, jokes apart, we can develop like this, or we can integrate IoT with all the existing technologies. Like we can integrate IoT with information security. That is the most what we can say demanding part nowadays, as because of this COVID situation. Now we all are working from home, so once a work from home is initiated, it is a very much comfort for us, but still it can impose some security threats, security risk, malware attacks. And if you can see, the rise in cyber attacks are more in this year than the last some few years. The data talks this now, and it is pretty true. And attackers can control your devices. Now, what kind of device attacker can control? If we talk about information security and how we can integrate IoT with that, you have a smartphones with you, so these smartphones can be hijacked. Now this is a very common example. Now you are having smart TVs. Now through that smart TV you can almost do every task what you are doing on the computer. So that again, computer is what any electrical and electronical instrument which is having a capacity to think. It is having a processor in it. So once the processors are embedded into a chip, and that chip is behaving like an intelligent chip. Now I'm not going into a machine learning now, but still, by having its partial intelligence, it is calculating the things and giving you the results. So whatever you do on your laptop, desktop computer, or a smartphone, you can do it through your smart TVs. It means that you can install your applications, you can use the applications, you can browse the internet, you can surf on YouTube or any kind of a video media, you can reliably record everything. Even these smart TVs are having small cameras embedded into it for your what we can say video conferences, so you can use that smart TV as a conference instrument. But if we see a bright part, it is very convenient, and if you see another part which is the darker one, if I'm a potential attacker, and if I manage to attack on your system and hijack your system, because most of these systems are working on a open source software. So I'm not blaming any open source tools or any open source applications such as Android or any other operating frameworks. I'm not blaming them, but because these are open in a nature, so if I'm an attacker, I can get the source code of it, I can read the source code, I can make the changes into it, and I can exploit it, means I can hack into it. And once I get a control of all these devices, I can always to look into your private space. So now if this is a smart TV and which is installed in your bedroom, then you can imagine the catastrophic events of your life, right? Because that TV is hijacked. And if it is in your kids room, or it is in a hall or something, then attacker can gather very much information out of that camera. Even you will not notice that camera is on. Even a camera is in front of me, that this is a USB camera what I'm using through to my laptop, as I purposefully purchase a laptop which is not having a camera. But still, for this kind of a video sessions where I wanted to show something, I use a USB camera. So a small indicator, a small LED light is glowing, or it is on in front of me, so indicating camera is on. But in an event of a hack, that light is not turned on, or that light can be turned off remotely, so you'll not notice whether your camera is on or not. Then your TV is having microphone, that microphone can be hacked. So there are limitless possibilities how the attackers can get the data. Even if you're surfing on a TV, then your most passwords, your credentials are taken out. So that can be things. So in that area, information security is most important. So IoT can be a very good match with information security. Even you can use IoT to develop security applications, that also you can do. So it is a vice versa thing. To protect yourself and from getting hijacked that device, information security is, or the cyber security implementation is required. And to have a cyber security part, like your fingerprint scanner, your iris scanner, so all these are what, these are the security instruments, biometric sensors. So these can be communicate on a IoT, or this can be come with the IoT capabilities. So that is both the win-win situations we can have with IoT. then IoT can be implemented with machine learning. So you can collect the data from your IoT devices and can forward the data on a remote place to analyze it, because these small devices are not having that capacity to get the machine learning model installed, and that model will that model will train itself, learn itself, and do something like that, because it requires a high amount of a processing power or CPU power, which these small devices are not able to provide. But there are some devices like Intel Smart Stick. So that Intel Smart Stick is developed for IoT, having a machine learning in mind. So that is a mini high-end CPU for IoT devices which can run machine learning models on it. Unfortunately, I'm not having that one with me. It is installed at my client's place, and it is very much restricted here in my area to move around because of this rise in COVID cases at my area. So that's why I denied to go at that place. So fine. Then that time you can have a machine learning on it. Even you can use IoT devices in automotive sectors to automate these things. So automation through IoT can be achieved in automobile and in normal applications as well. So automations can be there. So to have all these applications ready to work with all these applications, you need to have some kind of a stack, or you need to have some kind of a what we can say hierarchy to flow. So there is an IoT ecosystem which is getting developed because of this nature of requirements and the fluctuating in the requirements. So a very I'll take with this one, the 5 layer architecture, because these three are the most important layers, but these are already covered in this, so that's why I'm taking this one. Yeah. So at the very first layer, that is a business layer. We are approaching top to bottom moving here. So very first layer is a business layer. So this is a very critical, important, and needs to understand thoroughly kind of a layer. Why? Because here your client is giving you an idea what to develop, and how to develop is your way, that comes on an application layer. So what to develop, when to develop, and what needs to be performed when, these things needs to be understand first by the IoT developer. So we all are IoT developer right now. So if I ask you to create a weather station, so first job you will be taking in the mind that I'll be developing a weather station using Raspberry Pi. So I'm having a Raspberry Pi with me. Here it is. So I'll be developing it with Raspberry Pi. But definitely you can develop a similar kind of a weather station, or I can say a very cost effective and better performed weather station with Arduino, as it is a cost effective. So that is decision is a developer decision. Now the first thing you need to consider in the mind, that what is the business application of that weather station. So whether that weather station will be installed at your college premises, whether that will be installed at your office premise, whether it will be installed on some kind of a plant where some kind of factories are set in that factory plant. So depending upon the volume and depending upon the area where that application is going to be deployed, you need to select the things. So that's why your client will tell you a very basic things, or maybe sometimes very technical things, or very thoroughly everything what they want. Or if they are not telling you, that you need to clear it in a business layer. So manages the whole IoT system, including application, business, and profit models, and users privacy. So definitely this is a business layer, and where you need to understand the requirements, accordingly will be develop the things. And when that application is developed, that needs to be hosted. So that there can be a two parts of the application. One is a hardware part, and second is a software part. That both part we will be taking in this FDP. So taking on to a very basic example, that a weather station. So if we created a weather station to monitor a temperature, then monitor the humidity and all the other aspects what we can take in into weather station, even some smoke detectors and all we can implement on it. So this product what you have developed, a hardware product, can capture all the data and can alert you on the hardware part, but you need to take out that information and store somewhere, and later on you wanted to create a data set of it, and that data set need to be fitted into a machine learning, that kind of a approach if you are having in the mind. Or plainly you just need to see a very good dashboard having a very good design, a professional design, and you can see your data coming up onto it. So for that you need to develop an application which can, a web application definitely, which can be hosted on any other web hosting service, or can be on a IoT cloud platform, which is a very flexible and very easy to use services. Nowadays every cloud service providers are providing it, even Amazons are also providing it. So we will be taking example of Amazon IoT. Even you can get the Microsoft for this, but Amazon IoT is very user friendly and very easy to learn. That's why I'll be taking up that to start with it. So once you develop your skills into it, you can explore with the other IoT cloud services. So definitely we can create an application on it, and we can fetch data from device to here. So there you need to have a communication agent. So at that time you need to choose what kind of a communication media you want, and accordingly you can take a module for it. So of course if you wanted to communicate on a cloud using Ethernet cable, then you need to connect Ethernet adapter on your development board, and you need to program it accordingly. And if you wanted to throw information wirelessly, then you are having a very wide area and very distinct devices to choose from. Like you can have a WLAN card, you can have a WiMAX card, you can have a LoRa card, you can have a VPN card. So there are different kinds of a wireless media you can have. Even you can have a RF transmitter, you can have Bluetooth, you can have multiple wireless equities or multiple wireless equipment to connect with a single development board. So that development board can be your Android, can be Raspberry Pi, can be your Node MCU, can be your own created development board. Yes, you hear it correctly. You can create your own development board. What it requires just a proper systematical diagram of how the things will get flow. So that everything comes on a business layer. Now on the application layer, you will be responsible for creating the things and delivering the things to the client. Then on the processing layer, here on the processing layer, a IoT developer is responsible to see all the connections, then all the actuators, modules, sensors are taking it correctly or not, communicating with the your baseboard or a development board correctly or not. Your development board is throwing a correct input, getting a correct input and throwing a correct output. So all these things are do on the processing layer. Then you will be having a transport layer where the network layer is consist of this network layer can be into a transport layer. So you can decide what kind of a transportation media you want to deliver this message or to receive this kind of a message, means the information. And then finally there is a perception layer. Now what is a perception layer? This is a layer where your sensors are working together to sense the data, means to create a data, to capture whatever that sensor is programmed to do, and then that needs to be converted into a data, because whatever that sensor is collecting, that can be in the form of analog signals or can be form of a digital signals. Now if we talk about this Raspberry Pi Zero, so this Raspberry Pi Zero is a digital device. But if you talk about where it is, yeah, if you talk about this one, this tiny guy, so this is Arduino Mini Pro, which is an analog device. So though these are not only the devices, these are the development boards. So you can connect analog and digital sensors on it, but in a nature it is analog, in a nature it is a digital. Now why? Because all the Arduino types of a board, uh, not exactly all, the recent developments are changed nowadays, but most of the Arduino development boards are equipped with bootloader, and they are having a microprocessor in it. And most of the digital board like Raspberry Pi, Banana Pi and all, these are having ARM processors in it, which are the digital processors. So it means what? You can process things more on this, and with the more accuracy than this. So Raspberry Pi or any digital development boards are used on when you are having a large amount of data to be processed, that there you can use this. And if there are less amount of a data to be processed, or the data which is coming from the sensor, it is a one type of a sensor, means only the analog, only the digital, this kind of a thing. So you can use microcontrollers, and of course this cost more and this cost less. Fundamentally, if you wanted to use this into a normal application, then I'll suggest you always go with the Arduino, because these are very cost effective, or we can say cheap in the price. That's why if you mistakenly burn the board or you destroy any of the circuit, even you can replace the circuit, or you can throw this into a dustbin and you can buy a new one. But if you mistakenly destroy this one, because it is a possibility, if you give electric current which is more than its capacity, definitely it is going to be burned. So if it is beyond repair, then you need to throw it into a dustbin, and throwing this in a dustbin, it is a very painful task, because it's cost you almost 5 to 6,000 rupees depending upon the configuration again. So it is quite better in that case, right? Now if you talk about the compatibility of all these things, are it is compatible with any kind of a sensors. So as far as the digital development boards are having pinouts, so these pinouts are actually used to have your sensors and modules connect with this development board for checking out your connectivity. And once you are satisfied with your development, or whatever the application you have developed, then you can create your own circuit diagram, and you can have a PCB created for this, because pretty straightforward. This is a development board. So if you are taking any kind of a sensor, for example, I'm having one uh, PCB kind of a development, but it is a very compact development board. So if you can see this, are you all guys can see my screen? My video is clear, no? Everyone can
Yes,
see all the devices?
yes, sir. Yes, sir. Yes.
Okay,
Yes,
great.
yes, yes.
Yeah. So is my pace okay? Am I going too fast, or I'm getting too low?
Is it okay, sir?
Okay.
It is okay.
Yeah.
Okay.
Thank you. So if we can consider this one, so this is what this is a node. This is the ESP Cam 32, which is developed on a Node MCU platform. So as the name suggests, it is having a camera module on it. So these are the different types of cameras you can get. This is generally a 19 pin camera, or 16 pin camera, 240 pins camera. Now the application of this camera can be in various tasks, right? You can utilize this to create your mini CCTV camera, because it is having a very good capacity to capture. It is this camera, if the camera which is shipped with this board, it is having a 720 p resolution, so it is almost a 2 MP camera. But you can replace this camera to have a better resolution, and you can create a CCTV footage, a CCTV kind of application through it, which is a low power consuming device. But what this tiny device is having, along with the camera functionality, it is having a SD card slot. So up to 4 GB of a SD card can be read, micro SD can be read. Then it is having Bluetooth, and it is having Wi-Fi. So if you can see over here, this is another chip which is soldered, or not the soldered, actually it is embedded on this PCB sheet, the ESP sheet. Now this circuit is the circuit you are seeing in the square. This is a microcontroller of ESP8266. So ESP82, not the microcontroller, actually the controller only, controller IC. When you say microcontroller, it comes into a different way. Not to use the microcontroller word here, it is not appropriate. So this is ESP32 8266. Now this is only the ESP32 having Wi-Fi and Bluetooth. So it is very difficult to show you on here, but later on I'll just sharing you the pinout diagram, so there you can identify this very prominently. But this small device is capable to capture a live footage, store into SD card, or can communicate with the Bluetooth to a device, or can communicate on a network. If you are having any live streaming application installed, then you can directly do it on it. Okay, we are having a question. Please tell a difference between controller and a microcontroller. Okay, when we say a controller, that is means the IC, which is controlling the entire board and the entire functionality of this board. So whatever the functions you are putting, you can have a Bluetooth chip inside, you can have ESP chip inside, means the Wi-Fi chip inside, you can have this camera chip inside. So all these things is to be controlled. So that is what the controller, that is the IC. And the microcontroller is what it is also a similar kind of a thing, but only the thing is that microcontroller can control a single bit or a single point, like the only Bluetooth IC. So Bluetooth IC is responsible to control only the Bluetooth application. So that can be a microcontroller. But microcontroller is a collective term for all the controllers as well. So depending upon your application, these definitions can be varied. And if you go with the definition which is there on the Google, it tells different story. But let me tell you, this is very common to observe. Like whatever you have in a definition kind of a thing, those are the proven theories. But when you are applying this on a practical basis, so these things can be changed a little bit. So I'm just giving my thoughts on my observations, what I'm having while developing all these applications. So to develop a particular application, you need to see all the application layers as the stack process is going on. Yeah. Let me take out some development boards for you, so I can show you what kind of a boards we are having right now. Yes, we will be having a question answer sessions. But again, if you are having a very urgent question to us, just put it into a chat. So if time permits, I'll take them. Otherwise, I'll take it at the end. So let's not disturb the link. Now, another part is development boards. So I'll just introduce you what kind of a boards right now I'm having, and based on that, we'll see their structure. So I'll share their structure with the pinout diagram, so it will be very convenient for all you guys to see all the equipments properly. So the development board what I'm having right now, this is Arduino Mini Pro. So this is a very small development board, having just a quarter inch something. So let me pull out that circuit diagram for you, so it is very easy for you to see. I'll just present it. There it is, micro mini. I just downloaded it. Just a moment. Arduino pin out. I'll just pull it up through Google. Why it is not showing? uh, Better way what I'll do is I'll share my entire screen. So moving to the window is quite difficult for me. Okay, so this is pinout diagram for micro mini. So I guess everyone can see my video and my presentation side by side. This is better, no? Yeah. Or my video is not visible?
Also visible, sir.
Okay, great. So this is a Micro Mini Pro. So if you can see on here, let me show like this one. So you will be having some pinout, like you are having ground is denoted as a GND, so that is a ground one, where you will be sending it to ground, so extra signals can be grounded over there. VCC, now what is a VCC? VCC is uh, what we can say, it is a power in kind of a socket, because if you see on this development board, there is no outlet to get inside to this one. Like here you can have at least a USB on the Uno. You can have a USB connector and you can have a DC jack over here, so you can power this Uno with the DC jack, or you can even power this Uno through USB. And if you wanted to program the IC on the Uno, you can plug it to the USB circuit. But here, for a programming or giving it a power, there is no such kind of a area is denoted, or facility is provided. So what we can do is we can use TTL converters. So that is a small part I forget to take out from my shelf. So, and the second station, when we are interfacing some sensors with the development board, that time I'll show you what is the TTL converter. So that TTL converter is having a USB in, and it will be powered to this kind of a development board. So GND here, which is showing, these are the pinout for TTL converters. So GND is a ground, VCC is for the inside the voltage. So the maximum voltage what this development board can take is 5 volt. And then you are having a receiver and transmitter, so RX and TX for data transfer. Then on this board, what kind of pins we are having? Different pins. So whatever the pins which are denoted as A, so these are the analog pins. So analog pins can uh, give out, because these are the pin outs. So all the pins will be all the analog pins will be giving signals out and taking a signal in. Both way it is doing. It is not only just giving it. Whatever the analog sensors you will be having, those will be configured either on these pins. So it is having 4 analog pins, so it means that 4 analog sensors can be connected to it. Now you can expand these capacities with the expanders or expansion shield. So that I'll show you just a moment later. And whatever the numbers you are seeing, just 2, 3, 4, 5, 8, 9, 10, here the numbers what you are seeing, these are the digital GPIOs, digital pins. So digital pins which are having a digital modules or digital sensors, you can put those in this. Then you, if you wanted to take the input signals, mean the transmission signals from sensor or from module to this development board to process, then you can have TX and RX. Now the what these TX and RX will do, what is the difference of this TX-RX and this TX-RX is, the TX-RX, which is at the left side of a corner just above the reset button or the reset pin, these are the receiver and transmitters for the modules. So if you are having a Bluetooth module where Bluetooth signals are getting captured and Bluetooth signals are getting transferred, so that receiving and transferring will be done through this RX and TX. Now there is a fundamental rule. So if you wanted to communicate with the Bluetooth or any Wi-Fi or any kind of a device, then the TX, means the transmission end of the development board, should be connected with the receiver end of the sensor. Why? Because signals are getting transmitted by the development board, needs to be received at the sensor end. That's why TX will get connected to the receiver, that the RX on the sensor, and whatever the sensor is providing, means the TX transferring end of a sensor, needs to be received by a development board. That's why RX will be receiving the signal. So that is the fundamental rule every time you use, even for the TTL converter as well. So TX of the development board will get connect to the RX of a TTL board, and RX or TL of the TX of the RTL to connect with the RX of a development board. That is what. Then you will be having RST. Now, what is a RST? RST is a reset. So you will be having two type of a reset. One is a button reset, like here it is showing this is a button. So you can press a button once, then entire power cycle will be resetted on the development board. Means what? Your development board will be restarted. So that is the reset button. Then you are having in this configuration you are having two RST pins. Now these RST pins can be used as a reset pin for your sensor or a module. So if you wanted to reset your module on the power cycle, means you wanted to restart your module, then you can program RST and your development board's RST together. So you can have a switch button, a small button embedded on a development chip, and on that chip, once you press on it, automatically your sensor will get restarted. So that time you can have two RSTs. So two RSTs are here. Then you can have a VCC, another VCC over here. So this VCC is for sensor. So you want to give a power to sensor, so you can put VCC over here. Do not put your sensor VCC at this end. So at the time of the installation, I'll show you. Now this is a VCC out and this is a VCC in. Always remember for Micro Mini Pro. Now this is the most important part. This is a CPU of this small chip. So this is a Atmega 628 microcontroller, which going to control the entire circuit. Then we are having some capacitors, we are having ICs, we are having power regulator. Then here it is communication regulator diode. So all these are the what the supportive material or the supportive materials for this kind of a device. Even at the back of this device, it is showing that it is having 8 megahertz and 16 megahertz, 8, 16 and 20 megahertz the capacity to communicate. So RxTX is at low at you can configure it on the 8 megahertz, and as high as you can configure till 20 megahertz. So till 20 megahertz of a what we can say a module you can connect with this small chip. So almost you can have a WiMAX module connected with this. So that powerful it is. Then you can have a 3-volt out, and you can have a 5-volt out. So from here, so 3-volt and 5-volt out. So here on this diagram, this I think this is not the updated one, or it is another Mini Pro than what I'm holding right now. Maybe this is an updated version of this. So on this I can see extra two analog pins, if you can see over here, just above my finger. So these are the extra 2 points. Then you can have extra 3-volt out with the VCC. So it is denoted over here, I think ACC. Yeah, it is just before the ACC. So it is a 3-volt and 5-volt out. So this is what Micro Mini is all about. Then of course you will be having a header pins to solder with this and to use this one. Then another development board what I'm having slightly bigger than this, and having a USB connector, a micro USB connector. So this is Arduino Nano. So let me pull up that pin out for you. There it is. I think all are here. Yeah. Yes. So this is Arduino Nano. So it is somewhat different than this small guy. Again, in a size, it is slightly bigger than this, and having extra pinouts. So it is having almost 12 digital pins. So if you can see D12, so these are the digital pins. So this is actually diagram, a pinout diagram of the original Arduino board, not the clone one. That's why you can see D12, D1, D11 here, and I am having a first copy of it. So on the first copy you can see D1, D2, D3. So it is exact match. I worried that if I'm having just a clone version, maybe only numbers are printed. So again, it is, these are whatever the D's are there, these are the digital pins. Now you will be having two grounds, then you can have a 5 volt, two 5 volt in and out. So I forgot to tell you what win is. So win is volt in. So you can give a extra 5 volt over here or to the board. Sometime it happens like if you are interfacing this board with the another sensor or maybe a multiple sensors, and one of the sensor is analog and all are the digital and all are the analog, so kind of a thing. So in that case, if you wanted to give a more power, so to have another battery or power source connected, there is another provision for VIN. So you can actually do the power in. Even this VIN pin is a bidirectional pin. If you wanted to take out power from this, so 5 volt only you wanted to take out, not the 3.3 volt. So your digital sensor, like for example, if I'm having this display, this is the IC2 display. So this operates on minimum 3.3 and maximum 5 volt. So if I'm having IC2 displays like this, this is a 1.3 inch of a display. So I wanted to use this. So I can plug into a 3.3 volt, which is here. I can plug another to the 5 volt, and now I'm having another sensor to operate, because that sensor, whatever that sensor is collecting, that information is to be displayed on this. So that sensor is operating on the 5 volt. So where I can put it, so I can put that 5 volt over here. And if I wanted to work with multiple sensors, like 16 sensors at a time with nano, then I have to have an expansion shield. So what expansion shield is doing, expansion shield will expand its pinout capacity by producing an extra layer. So this is the nano expansion shield, where if you can see the bug strip over here, female bug strip, here your nano will go just like this. Your power pin needs to be uh, directionally, the power pin needs to be at the same direction where the power in is here at the expansion shield. So once you press like this, yes, it is ready. Now what this expansion shield will do, this expansion shield will take all the pin in here at the circuitry, and can produce lot more pin outs. So here is the lot more pin outs. So these are the 1 2 3 4 bunch of a pin out. So each pin, the first starting pin is ground, another is volt, but that is the voltage power, and then another one is a signal power. So all are the volt powers will give a 5 volts signal. So if I am having 4 4 4 4 16 sensors, if I wanted to connect, I can connect with this node MCU using expansion shield. So this is a nano expansion shield. So each 5 volt is a 5 volt of a analog or a digital sensor I can configure. Even if you wanted to have just analog sensors to communicate, then 1 2 3 4 5, even here are the 8 analog pins out. So 16 sensors, maybe it is analog or a digital, can work on here, and only analog signals which requires a very controlled power, then you can power it here to the analog. So this is a specifically created for nano to expand its capacity. Even if you are having a module which needs to have a TX-RX, again there are the TX-RX pinouts as well. So you can put 1 2 3 4 sensors which are having RX TX to it. Now this is a very mid-range kind of expansion shield. You can have a more pin out in a different layout, or even you can create your own. Now if you can see over here, these are the pins which are unsoldered. So here I can solder a thing, and I can have almost again 2 TX over here. The ratings are written over here. So 2 TX and all other are digital, and then I can have a one more RxTX. So that way I can expand it. So if I wanted to use more than 10, 16, 20 connectors with this, so this is what the uh, nano is. Then if you can see SPI and SCK, then I2C data, I2C clock. What is this? This means where is the So this means that here are the two types of a displays. The one which I am holding, this is a I2C display, means this one. So I2C displays every time have four pins, like here, these are the four pins. One is to power this, means the VCC in. Another is a ground, that power needs to be grounded. Then another one is a data, and another one is a if this device is working with a system clock, then that the system clock. So SPI and SCK talks about system calls, and data and clock talks about the clocking. So if you can see, all these things are written over here with the pinouts. Right. Then another development board what I'm having here is, let me take this. Yes, the most recommended favorite of all is Arduino Uno, having Atmega a 328P chipset. So this is the IC. This is the IC, which is this is the IC, which holds all the information. Like here also, the same chipset is there. This is the Atmega 328P. Only a difference is this is a embedded chip, means this is a SMD chip, and this is a reprogrammable IC. So what is the benefit in this? So if you are having a pre-programmable IC, and by mistake if you fried the circuit, the IC circuit, you can easily replace this IC just pulling it up, and you can buy a new ATLGA 328P IC, or what exactly this is. The ratings you can see over here, exactly the same ratings. You can put it again, you can load the bootloader. Loading a bootloader is very easy. You can take out the another chipset, do the pointings, and you can transfer the bootloader into it, and then you can reprogram this. So this is maintainable and very easy to maintain. But if you overclock or burn this SMD IC, now it is very difficult to place, because it required some experienced and what we can say a professional tools to solder this on, because these are having a very tiny circuits to be connected. So we will not afford to connect it reversely. Maybe again it can damage the board. Okay, by coming on the part, this is a most stable development board, and having a very what we can say a sturdy look. It is having, here it is having a digital pin in pin out, and here you can see all the analog pin in pin outs. So this is the pin in pin out diagram of it. So ultimately it is having IC2 SPI pins, where the IC2 kind of a displays can be connected, and you can have a separate indicator for L and RxTx. Now L is what? L is for LED. If you wanted to see the status or something, you can blow that LED on and off, and you can have RxTx status by just visually confirmation. If you wanted a visual confirmation whether your Bluetooth is receiving your signal and your development board is receiving Bluetooth signal, so RxTx needs to be checked. So these are the difference. Then you can have capacitors which can capacitate the power, because it is having a direct DC in. So it works on 12 it works on 230 DC in, having 12 volt 1 ampere as a power sock. More than this may cause fire, so don't attempt to do it. Even 1.2 ampere also not operating on this. You can burn the board. This is the Uno. And then we are having a big brother of Uno, that is Mega. I can pull up that for you. Only the difference here is it is having much more pin out for a digital and for analog. Almost all pins are a digital pin. You can see 52 digital pins you will be having. So also the sensors you can integrate it more than 52. Also you can integrate with the expansion shield. So for the every development board in Arduino, even for the Raspberry Pi, expansion shields are available, or you can design your own expansion shield. other structure is same, like you will be having a normal USB connector or a DC jack, then the power regulator ICs, you can have a microcontroller regulator IC. Then the difference here is it is having Atmega chipset is the same, only the thing is it is a SMT chipset. um, they have not implemented IC kind of a structure. Then the big brother of Mega is Leonardo, Arduino Leonardo. So unfortunately I'm not having Arduino Leonardo with me. Then here it is, the Node MCU. Now, what is a Node MCU? It is again open source development circuit or a development board. Only a difference is, like we saw in ESP CAM, it is having different configuration. Like it is having a chip where a Bluetooth and Wi-Fi is embedded. So it is totally depend upon what kind of chip you are buying. So this chip is having only Wi-Fi. It is not having Bluetooth. And if you wanted to confirm it, you can read it over here. So let me pull up the diagram for you. Yes. So if you can read here, it is better for you now. So it is showing Wi-Fi as a visual confirmation. So similarly here it is also a Wi-Fi, and then ESP8266 MOD, and it is having ESP8266 MOD. It is the exact match with my diagram. Now, why I always say exact match of a diagram, because again these are not the what we can say uh, structurized one, but the diagram or everything is not structurized. So if I wanted to customize this according to me, I can customize and I can print this boards. So it is very easy in that case. So though it is having a 8266, it is having only Wi-Fi, and if I can see this one, it is having Wi-Fi as well as Bluetooth. So this chip is a different and this chip is a different, and altogether with chip and a development board, it is chipset, right? So this is a Node MCU development board. In a Node MCU also there are three types. One is a ESP32. Once we say ESP32, it means that it is having Bluetooth and Wi-Fi both. When after that, it is a Node MCU with chipset of CP2102. So 2102 is what? It is a microcontroller. So if you can see over here, so tiny one, this one. So this is a microcontroller what is controlling it. So this is a chip one. I'm having a Node MCU one in my box, so I'll take it out at later, which is a version 1, which is having a different CPU chip. So that is not that concern. Then it is having a flash and RST button over here. Then it is having all digital pin. Only one analog pin is available with this. So if you wanted to interface analog sensors with Node MCU, then you have to use analog multiplexer. Their analog shields will not be in use, as the shields are not getting configured with this, but you can have a analog multiplexer which will be multiplexing your analog channels, because shields will not able to multiplex it in a node MCU case. Only the thing is those base boards or base shields can what we can say increase the pin outs of a digital pins. So the boards what I have shown you, those are the analog and digital base boards, which is having a both analog and digital pinouts to communicate with it, but working on the microcontroller. Now here I'm having a sensor shield, which is an expansion shield for Arduino Uno. So you can now see all these are the pinouts. So these many sensors I can put, almost 58 sensors I can put on the single Uno. Similarly, I'm having expansion shield or a sensor shield for a Mega. So altogether Mega is providing on board 52 pins, and with the sensor shield installed on it, this is a 52. So that sensor shield is of, I think, of 186. So 186 plus 52, that kind of a pins you will be getting. So you can imagine a one single microcontroller or single development board can control how many devices, right? Or what kind of a structure you can have, a very humongous structure you can have it. Now let's talk about the digital ARM boards. So these are what? These are the microcontroller board which is having a controller IC to control each and every movement, though it is slower in performance and it is not equipped to handle complex, very complex tasks, not only the complex, very much complex tasks, like for example, machine learning. So machine learning cannot be processed through Mega, Leonardo, Uno, whatever the size is not matter over here. The controller, what at Mega is. So at Mega is not that much capable to have all the processing done. So you can might change your development board if you are having that kind of a resources to program to the digital board. So this is what this is a Raspberry Pi 4 having 2 GB of a RAM. So here there is no RAM as such. There is a flash memory. Now here you will be having a flash as well as RAM as well as complete storage as a SD card slot. So you can install up to 128 GB of a SD card over here. So if I slightly change the configuration of it by removing this SD card slot, and here is the SD card controller MD, once I replace this I can increase the size, but it is very risky to do it because Raspberry Pi is not an open circuit, so it is very difficult to examine each and every circuit. If you are from electrical background, then you can easily read the structure and you can make the changes, but again it is difficult because it is having a very neat and clean design on it. Then you can have here it is the HDMI display slot. So it is not looks like the HDMI port, as you can see over here. This is the normal C type connector, and these are the two micro HDMI slots. These are not micro USB, these are the HDMI, and one is the HDMI and one is the micro SD. It is written over here, depending upon that. So this is what, this is a flip boards. So you can have a digital display. Even I can hook my LCD to this, even I can hook my TV to this. So based with this, that flat wires, so this we can do. So they're digital. Then we are having two 3.0 USB connectors. Then we can have a one RJ45 connector. Then we can have two normal USB connectors, so 2.02 and 3.02. So these are the four USB connectors you can have embedded on a chip directly, and one USB. So this is pretty much a computer. It is having a 2 GB of a RAM is over here. It is having a ARM processor. So this processor is a Cortex processor, I think. So I need to check its data sheet what exactly the processor is, because this is the latest model, Raspberry Pi 4. Maybe a Raspberry Pi 4 and advanced Raspberry Pi is already come up into a market, but recently I brought this. So you can use this Raspberry as a mini computer, and you can control everything what we can do. The smaller version of the same thing is this one. This is a Raspberry Pi W0. Only the difference is this board is having only Wi-Fi connection, I think so. Sorry, it is not having a Wi-Fi. It is just a development board because it is having a RJ45 in. I have not taken up that variant which is having a Wi-Fi and Bluetooth. Why? Because I have, instead of that, I have purchased Raspberry Pi Zero. So this is a smaller version of the Raspberry Pi. So Raspberry Pi Zero will not usually come with the header pin soldered in. It can come with the non-header pins, like your this one, Pro, Mini Pro. So mine also shipped with non pins, so I've soldered those pins. Or even you can get a soldered pin for 200 rupees extra when you cost it. But okay, so this is the Raspberry Pi W0W, which is having a Wi-Fi and Bluetooth chipsets. Even it is having a micro HDMI slot and two micro USB slots. Even it is having up to 128 GB of a SD card slot, so I can program this. Now again, a big difference in this kind of ARM chipsets and bootloader chipset is this will require a IDE, that is interactive development environment, to program this board. So you can develop your program in Arduino IDE like this. This is a basic Arduino IDE. You can program your whatever you wanted to use, and you can what we can say, burn this program in this chip using USB. Now here you need required Raspberry OS, so it is called as a Raspberry or Raspberry OS, which needs to be installed at your computer. Wow, and your board needs to be connected with that. Maybe software can do, software is also there, so you can connect with that and then you can programming, or else you can burn your SD card with Raspberry in OS. You can insert that SD card in SD card slot and just connect your board with the computer. Rest of the things can be configured through SD card. So that is the thing in this, right? Yeah. More on this. Yes, so to be in the market, like Arduino is a favorite choice for beginners or favorite choice for all IoT developers to start with the development. But again, Arduino thinks like they can expand their footholds and into a digital market as well, or to compete with these kind of a board, Raspberry or baseboards, all other kinds of a baseboard. So they have developed these kind of a development chips. So this is the most advanced Arduino. Now this is ARM based processor equipped with almost teflon of a memory, kind of a memory. They claim it. I don't know. I have not tested it yet. Just brought 5 days back. So this is Protenta H7, Arduino Protenta H7, which is a genuine Protenta. This is not a clone copy. I have purchased through Italy only, online, of course. Then it is having a ARM processor right now here. This is the ARM processor, which is a 10 times faster than the Raspberry processor. Now, because of that kind of a capacity, we can almost integrate machine learning model in it. But I'm having a doubt how we can install this. So Protenta, it can be stack on a Protenta shield, where these kind of RX45 and all these kind of uh, sensors are, or the modules are already on chip, and there is a SD card slot as well, so you can put a SD card into it and you can save your machine learning model in it, and then this will process it. But if similarly, if you can do this like this, there are the SD card reader and writer modules available to integrate with the development board like Mega or Uno, but they are not that capable, or this development board CPU or the microcontroller is not capable to run machine learning models, but this will do. Again, it is having a wireless antenna. So this is a WiMAX antenna. This is a small tiny antenna over here. That is a detachable antenna like this. You can put it like here. So this is a detachable antenna having almost a 5 gigahertz of a transmission field, means what, almost 3 kilometers a range. So this is the WiMAX one. Even it can communicate on the LoRa band as well. So LoRa is again a technology. So you can almost what we can see, you can almost expand your reach through always these things. So Arduino is also taking their efforts in digital media, and they are producing these kind of devices. Right. So I guess we already have a very good interface, or the introduction to interface with all the devices what I'm right now I'm having handy with me. And definitely to program this, we are having a bunch of cables as well. So in our next session, what we'll do is we'll try to configure, we'll write a single program like the program I have written over here. So we'll write a single program for LED blink. Let's start with the LED blink. Like we used to write hello world program in our programming languages. So in IoT, we start with the LED blink. So let's start with the LED blink, and later on from tomorrow, we will be throwing some problem statement, and accordingly we'll create some application like weather station or something. So you can be familiar with all the different sensors what we can have. That sensors, I'll demonstrate all the sensors in the next session only. So that all we will be interfacing with this. Right. So right, for this session, we're open for question answers. If you are having any, please do ask. Even you can unmute your mic and ask, or you can write it into chat. Yes. Are we having any questions? So I think there are no questions. So we'll take a break and we'll meet for the another session. Yeah. Okay. Thank you very much.